So this question wants to use the same understanding of your zeros to create an equation and then find all of the pieces for it. So if we have our factored form of an equation, depending on what your teacher taught you, a x minus s, we use x minus t. We use s and t. Some people use t and r. Some people use s and r. It doesn't matter. That's what we use at LaSalle. It changes from teacher to teacher, truthfully. This is our factored form of equation. If we have information, we can put it in here. If we know what the zeros are, we could replace this value and this value with zeros. And we have that. Okay? The other thing that we were given is a coordinate. And a coordinate's made up of two parts. It's got an x piece. So we were given this. And it's got a y piece. So we were given that. The only letter that we weren't given was the a value. And that's what you have to solve for when you're creating this question. So I'm going to start just by plugging in the zeros. That's always where I get the students to start because we got to do a little bit of thinking there. So y equals a x. If the zero was a, so this is the math that happens. That negative stays there and you plug in your 0. And then here's our other x. The negative's there, plug in that 0. Okay, I'll put it in brackets just so you see what's happening. The math does this. When you subtract a negative, that's like adding. And here, when you subtract a positive, that's like subtracting. So notice that the 0 was at a -4, but the equation ends up saying +4. And the 0 was at a +8, but the equation ends up saying -8. That's why when we're doing these tricks, we're like, oh, you just do the opposite of what is in the equation, because this is what it originally meant. But being like, well, the original equation is a negative, and when you are undoing a negative, it has to be like, no, just do the opposite. Okay? So, we've got our equation set up, and we plugged in our zeros. Awesome. Let's plug in an x and a y value that we know. So instead of y, I'm going to put in 18. I don't know a, and then instead of x, I'm going to plug in a 2 plus a 4 and a 2 minus an 8. This is an 18, this is an a, this is a 6, this is a -6. Okay, okay. Mental math at its whoopsie-daisies finest. Boom. Okay, so don't forget that the math happening between the a and this value right here. So I multiplied right here. I went -6 times -6, or sorry, +6 times -6 to give us a -36. But then this is also multiplication happening right here. So when we're looking to isolate for a, you have to divide. If you do it to one side, I have to do it to the other. We do a little bit of that. We do a little bit of that. Now, numbers that come out of both 18 and 36 would be 18. This is a -1/2. Okay, so the equation always has the letter y and x in it. Yes, for quadratics it does, until grade 11. You change this. But for grade 10, y and x's. So y equals, we have to put in a number for the a, we leave the x, and then we have to finish the equation that we had up there. +4x minus 8. So that's why I have students do this step, is so they can see what the original equation was, but then they replace it back to x's and y's.